The Gertrude Ilion grew up in New York City. Her grandfather died of stomach cancer in 1933. She decided to become a scientist to fight the disease. In 1937, she graduated from Hunter College with a bachelor's degree in chemistry and earned a master's degree in chemistry from New York University in 1941. Her fiancé died of an infection around this time. Miss Ilion committed herself even more to her work. In the 1940s, the gender discrimination was a common problem even in the United States. University after university rejected Miss Ilion's application to a doctoral program. She eventually found a position in a drug company, which is now known as GlaxoSmithKline. Over the course of her decades-long career, she developed 6 drugs. Her discoveries are remarkable. Since most scientists who work at pharmaceutical companies are lucky to discover one drug during their career. In 1988, Miss Ilion shared the Nobel Prize in Physiology or Medicine. She invented a new way to design drugs against infectious diseases and cancers. The many anti-cancer drugs, antibiotics, and antiviral drugs are found not by using a logical design, but through random trial and error. Miss Ilion chose to investigate the differences between normal human cells and cancerous cells or cells infected with pathogens such as bacteria and viruses. Focusing primarily on nucleic acid derivatives, she realized that simply stopping DNA synthesis would have serious side effects on normal cells. Consequently, she invented the methods to design drugs that would attack and selectively kill only cancer cells and pathogens. Let me show you one famous example. Acyclovir is one of the drugs that Miss Ilion discovered. The chemical structure of acyclovir is shown here. The structure of acyclovir is very similar to a DNA component called deoxyguanosine. Acyclovir has an incomplete sugar ring. When this ring is incorporated into DNA, it results in premature chain termination. In other words, DNA elongation is inhibited, and the virus can no longer replicate itself. But why does this drug attack only virus-infected cells? Phosphorylation is needed for acyclovir to be active. Without phosphate group, acyclovir cannot be incorporated into DNA. The target virus has an enzyme that initiates the phosphorylation of acyclovir. That's why the drug is active only in virus-infected cells. The normal replication process usually takes place in the following way. Number one, deoxyguanosine is incorporated with its 3 phosphate groups into DNA. Then G pairs with cytosine, C. Then G is incorporated into the elongating chain on the other side of C. On the other hand, when ascorbyl is incorporated with its 3 phosphate groups, DNA elongation is inhibited because no hydroxy group is available for the next nucleotide. This results in the chain termination in virus-infected cells. Ascorbyl clearly exploits the existing biological system. In the next video clip, I will show you example of anti-cancer drugs that target DNA.